from Cairo, Egypt. He's the pride of the School of Engineering and Applied Sciences, and he'll tell us, whether we want to know or not, how to swim without dying in poop water. I don't know what else to say other than to have you welcome Abdul Rahman Hasabala. All right, for our final one of the day, you guys want to all help me with the last thing I'm supposed to say here? You ready? Ready, set, pitch.
Whether you do it first thing in the morning or prefer an evening session, most of us here, once relieved, tend to use water to flush away our poop. Sometimes, as in the case with me, it even takes 2 flushes. It's a dirty business we all partake in, but tend not to think about it once it's all gone. Now imagine if all that poop water did not go away. Instead, it's sitting around in our backyards or collecting in Lake LaSalle. We would be living in a public health nightmare. My PhD focuses on how we can use organic and novel techniques to treat sewage. We as humans treat sewage through extensive sanitation treatment. Sanitation treatment is important for society to function, and according to the British Medical Journal, it is the most important medical advancement of the past century and a half. Now, there are many steps to how we can treat sewage. One of those steps is through disinfection by chlorine to kill off pathogens, bacteria that can make us sick. Once sewage is treated, we release it from treatment facilities into the swimming pools of nature, such as rivers and lakes. We recently learned, however, that small amounts of chlorine, just 100 micrograms per liter, can remain in this treated sewage, and when released, it can be harmful to the environment, toxic to fish, and carcinogenic to humans. This can happen here every summer when combined sewers overflow into Lake Erie. It is an alarming wake-up call, and there is a need for an alternative disinfectant suitable to treat our sewage without harming the environment. That is why I'm investigating the effects of organic acids against bacteria found in sewage. The word acid may sound a little scary, but the kind I'm studying is called peracetic acid, and it's not very different from vinegar, the salad dressing vinegar. And when released, it's relatively harmless. Peracetic acid is more expensive than the traditionally used chlorine, but it is not as expensive as other treatment options already established in the industry, such as UV or ultraviolet light. But then again, anything worth having doesn't come easy or cheap, especially when it comes to water, Earth's most valuable resource. I'm proud to say that my research serves as a critical contribution towards leading the way in understanding how peracetic acid works, not only against bacteria, but also against viruses, parasites with their own slew of diseases and health effects. The research is novel because I also investigate the effects of peracetic acid in combination with established methods like UV. I do this using pilot scale studies at treatment facilities in addition to laboratory scale experiments here at UB. This allows us to understand its scalability against a wide range of fecal indicators. I believe it is research with big implications that can positively disrupt the industry by safeguarding the health of society and the environment we are inherently a part of. Thank you.